Welcome back to Coding with Kyle. This is episode 2 of the IC Avatar Developer Series. In this episode, we'll show you how to set up a basic Motoko canister with create, read, update, and delete functionality for a resource of profiles. Let's jump right into building our application in the Motoko playground. We'll start by declaring an actor. And now we'll need to define our data model. Our main thing that we'll be storing will be profiles. And so let's start by adding some biographical information by declaring a type of bio. And then we'll have a number of fields that the user can enter, such as given name, as an optional value of text. I'm using given name as the HTML autocomplete attribute uses given name and family name for things like first name and last name. So I'll be following that spec here. This biographical information will go as one attribute of our profile. And that's enough to get us started. Now let's look at how we're going to persist our information. So we want to have data that can persist across updates to our canister. So Motoko provides a stable interface. Only certain types can be stable, but we're going to use one here. A stable variable, which we're going to be able to rewrite when we need to. Profiles. And this is going to be of a type try. Which we need to import from the base library. So the try here is functioning essentially as a key value map. And we're going to be able to store values here with nats as the key and profile as the type that we're storing. We'll initialize that with try.empty. And for that nat, we're just going to use a simple incrementing ID for this stage of the application. So that'll be another stable var, next, of type nat, and we'll start with 1 as a simple positive integer. Now let's code the functions that are part of our application's interface. To create a profile, we'll declare a public function named create, which accepts an argument of a profile of type profile. And this will return an async Boolean value. If we return true, that means that the task was successful, and false if we failed. Next, we'll use our stable var next to create a profile ID, which we can then use as our key in the try. We'll return true as our base case, just so we get a Boolean result. So now we've got our profile ID, which for the very first instance will be 1. we can then increment next. Now we will declare our interface to insert into our try. So the method that we'll be using is try.put, which has 4 arguments and will return a tuple of the new profiles, so the resulting try from this operation, and existing, which will be the value at the key which we're about to specify down below. So argument 1 is profiles, which is the try that we are going to modify. And now we need to specify a key that we want to insert our profile at. To get this key, I'll declare a private function which accepts an argument of type nat, and it's going to return a try.key of type nat. So what this will return is return key is equal to x, and the key type here needs a hash of type hash or nat32. So what we're going to do is use hash.hash of x for our nat. And we will need to take that hash and import that at the top of our file. So with this key method, we can come back to our create here. So we are going to insert at our tree with a key of our profile ID. And now the third argument is looking for an equality checker. So we will use the one that's provided by nat. And this will use when the key is doing like its find function, this will assess the equality. And now we've previously been referencing nat because it's a built-in type, but now that we're using a property of it, we need to import that as well. And then our final value is going to be the profile that we want to insert, which we'll get from our argument up above. And now for some additional safety, we're going to go ahead and check to see whether there is an existing entry, in which case we don't want to do our create process. We'll do this with a switch statement. So here, if there are no matches, which can be case null, if existing is null, then we will rewrite profiles to equal our new profiles with the inserted profile. And in the case where there is an existing profile, we will do case of optional value, which simply signifies that there is some value there. We will return false because we do not want to create a new profile that matches an existing one. And that's all it takes for us to create our profile. The next method of our interface will be reading a profile. Here we have another public function of read, which takes a profile ID as an argument, and it will yield an optional profile. This means if we find a profile, we will return it. Otherwise, we will return null. Here we can use the try.find, which will take 3 arguments. Our try of profiles, a key of our profile ID, and our equality checker. Because the result of this operation is already an optional profile, we can simply return our result. The next function that we will go through is updating our profile. Public func update, which accepts a profile ID and a profile which will overwrite the profile at that ID. Like create, this will return an async bool. We can reuse our finding logic. And now we can do a switch statement based on the result here, which will be an optional profile. It's either a profile or it's null. So if there is no profile, then we will not allow an update to be written. But if there is one, and if we have found a profile, we will then overwrite profiles to the result of try.replace where we have profiles, our key, nat equal, and the profile that we want to overwrite. And since replace is going to return a tuple just like put does, we will then take the first of those, which is the replaced try, and use that to overwrite profiles. And in replace, the final argument is an option. So what is happening here is that the try will take profiles, look up a key for our profile ID, use this equality checker, and it'll write our profile to it. Then the result of that is a tuple of the new profiles and any existing at that entry, and we take the new profiles and overwrite it to profiles. So that updates our stable memory. And then since we're successful, we return true. For delete, we can take almost exactly the same information, rename it to delete, and here, when we replace, all we need to do is replace it with null. And just like that, we have full CRUD functionality for our application. Let's see what this looks like in Candid UI. Let's create a simple one here. I'll name this Hello World. We get back true with our response. We can now read that information by calling a profile ID of 1. There's our response. We can update profile 1 and have the name be test. We get a true response. We can even verify that with read. Opt test right there. And finally, we can delete profile 1. Which reminds me, since delete, we don't care about replacing the profile, we can remove that argument. All we need is a profile ID. So we've now deleted, and we can check again. And just like that, profile 1 is now null. So to summarize, we defined our actor, we created a set of type information as well as an interface to access our actor, and we gave it create, read, update, and delete functionality. For the next episode, we'll look into how we can upgrade this so that right now, currently, anyone can access any of the profiles, they can make modifications to them. That's not going to be useful for a larger scaled database. So I'll show how to use authentication so that each user can only interact with their own profile. We'll also look into upgrading the result types so that we don't have to rely on a Boolean true or false, and we can pass some more useful information like error messages along with that. That's it for episode 2. I look forward to seeing you next time.